To perform the LM test on slide 13, we need to open a new set of data, and that is BYD. It's called BYD in our dataset folder. So essentially, we are going to estimate the linear regression model with an intercept term only. Then we use the residual to perform this test and check whether we have a AR-Arch1 effect. So let's go back to stata first. So in stata, firstly we need to open the data. It's called BYD and then generate a time index. The data is ready for analysis. And the regression model we need to estimate is just regress R. There is no dependent variable. The value of this R is constant. The mean is constant. So we just estimate intercept term. Then if you submit this regression model, submit this command line, that will give you this coefficient estimates. So that's what we had in the PowerPoint. Then the next step is to store the residual from this regression in a new variable that's called E hat. Then we need to calculate the value of E hat square, because that's the variable that we're going to use in our test equation. So we generate a new variable that is called E hat square. That's just the square of E hat. Then we regress the lag term of, we regress this variable on its lag term. So regression, or REG, E hat 2 on the lag term of E hat 2. That gives us this regression model. So you may notice that our square is 0.1246. That is the same as the one in my PowerPoint slide. And I also have the correlation coefficient over there, and it's significant. So what we need to do is to perform an LM test. You can either test it manually, or you can use a stata command. So if you want to open the black box, here are the command lines. We calculate the test statistics to be n times the R square, and we can calculate the p-value by using this function. It's similar to the function, the distribution functions in Excel. And the critical value can be calculated by using the invert function of a chi-distribution as well. The degree of freedom is 1 because it's only one lag, and the significance level is 5%. So we can display those values, and you may notice that they are the same as the ones that I mentioned in my lecture. So this is to perform the test manually if you would like to know how to calculate those statistics. Alternatively, we can use a command called LM. So we run a regression model first. Then immediately after the regression model, we request statistics. That's an LM test for arch effect in the residual, and we consider one lag only. So this is the meaning of this line. If you submit those two lines, that will give you, if you make a comparison, the chi-square test statistics is the same degree of freedom, the same probability. Okay, it's a very small value, so that means it's very small. It's essentially the same as this one. So in practice, I just use this command line to check whether I have a arch effect in my residual. If yes, I'm going to fit an arch model. So this is how to perform the test. The estimation of an arch model actually is quite straightforward in stata, because there is a command for this type of analysis. It's called arch. If we use arch and we specify R is the time series we would like to model, and we would like to model an Arch1 model only. So that's the command line. That's all you need to do. Submit this line to stata. As we mentioned before, it uses a maximum likelihood method. So it will iterate, and once the convergence criteria is met, the whole process will stop. And that gives us the final answer. And we have the value of R and the coefficient of the arch effect as well. Or as shown on my PowerPoint slide, on slide 14, we have the Arch1 model result. Those are the coefficient estimate we obtained from the analysis we have just carried out. And the next step is to estimate the value of ht plus 1 hat or do some forecasting. Let's go back to stata to demonstrate how to do so. So in stata, after we have estimated this arch model, the variance actually has already been calculated, but it's in the memory. It has to be retrieved and put into a variable. So we use predict to request the system, the software, to store the value of ht hat into a new variable. It's called arch1 hat ht arch1. So it's arch1 model, and that's ht. So the value will be stored there. Once you press enter, submit this line, you may notice that in your data list, there is a new variable, and that's the conditional variance. And it's one step because it's arch1. Then you can either use the data window, open the data window to have a look at the data. Alternatively, you can use this ts line command, just like this one. You can have a look at the pattern. So that's the same as I included in my PowerPoint slide. That's slide number 15.